Welcome students. In this particular class we will be doing problems involving consistent and inconsistent linear equations. So the general way that they would ask you these questions is that they will give you a pair of linear equation and they will ask you to check if the given system or the given pair of linear equations are they consistent or inconsistent. So before I could set off in the problem solving mode, let me give you the recap, the requirement for a pair of linear equations to be consistent or inconsistent. Now, along with being consistent and inconsistent, there is something called as dependent and consistent. So this is also an important categorization. Okay, so let me give you the conditions under which the system or the pair of linear equations can be termed to be consistent or inconsistent or dependent and inconsistent. So the first condition is, let us take the following pairs. Let us consider a1x positive b1y positive c1 is equal to 0 and a2x positive b2y positive c2 is equal to 0. So this is the system. I'm using the word system because as you move up in your education, this is how they will refer to equations in general. So that's a side note. Now, having got this, the first check, this is check number 1. You got to take the value of a1 and divide it by a2 and see if it is equal to b1 divided by b2. If it is not equal, then suppose you are drawing the graph for this, the graph will intersect at one point. The graph will intersect at a unique point. Of course, I'm using an indefinite article. It's okay. You can also use it. You can also use an. It doesn't matter whether you use or an because we are not in the framework of studying the language of English, but the language of mathematical communication. So the graph will intersect at a unique point. When I say unique point, it is the point. You wouldn't have any other intersection apart from this. And the outcome would be, what would be the outcome for this? The outcome is unique solution. And you will get only one solution. Have that in mind. There is no S there. So only one solution. So the graph would look something like this. If you have a line coming down like this and you got another line going like this. So this is a line and this is a line. So the intersection is, this is the solution. So this is going to be some x1 comma y1. And that will occur only if this condition holds good. Now let us go to check 2. Having given you this, let me move on to check 2. On the other hand, if you got a1 divided by a2, if it is equal to b1 divided by b2, if it is equal to c1 divided by c2, c1 divided by c2 is constant. If this is the situation that you are getting, then the graph is called as, the graph will consist of coincident lines and the system. So as I mentioned to you, when I use the word system, it means the pair of linear equations. The system will have infinitely many solutions. solutions S, and such a system is called as dependent and consistent. Over here, this system is called as consistent, and this system is called as dependent and consistent. So let me underline this. These are all important keywords you will have to know. This is check 2. So how will the graph look? You have, this is x-axis, x-axis, y-axis, x-axis, y-axis. Now suppose you have a graph, the first equation is moving up like this. The second equation will also flow over it. The system will be flowing over it, the second equation. And this is what is called as coincident. All the way, right from here, it will move up. Both of them will be one over the other. So none of them will be greater, none will be smaller. They will be in tandem. The keyword is tandem. One over the other. So have that in mind. And having given you this, let me go on to the third one, the third check. This is the third check 3. Now you are getting A1 over A2 if it is equal to B1 over B2, if it is equal to C1 over C2, then the graph will consist of parallel lines, and that would mean there isn't any intersection, and if there isn't any intersection, there would be no solution. So this means the system will have no solution, will have no solution. Right? So how do you draw the graph? So the graph would be of this fashion. This is x-axis, y-axis, and I have a line going like this, another line will flow like this. It need not be in this fashion. I'm just giving you an illustration. So if they were to give you the graphs, they can also give you the graphs, right? They can say identify the graphs as consistent, inconsistent, or dependent and consistent. So this is the most important term that you have to know: dependent and consistent. Some of the textbooks and online videos which I have seen, they are only talking about consistency and inconsistency. Well, there is also the third category, what is called as dependent and consistent. So what is the point in terming this to be as consistent? Right? In this case, this system is actually having infinity number of solutions. There is a large difference having a solution and having infinite number of solution. Why is it able to, or how is it having infinite number of solution? The system is having infinite number of solution for the very fact that it is falling into the category of dependent and consistent. So have that in mind. Having mentioned all this, let us go on to problem solving sessions. Now you might be asked to either to use graphical method or algebraic method. So they can ask any of these two things, either graphical or algebraic. So I'm going to show you how to do the both the ways. So you are given check for consistency. So this is the question. Question 1, x positive y is equal to 5, and the other equation is 2x positive 2y is equal to 10. What I would do is, it doesn't matter, you don't have to bring this constant to the other side. You can just add this constant right where it is. So in this case, this is going to be a1 is equal to 1, b1 is equal to 1, a2 is equal to 2, b2 is equal to 2. I should also write c1 is equal to 5. You can place colon, colon or semicolon, and c2 is equal to 10. You can use this phrase, let us consider a1 over a2. What is that equal to? 1 over 2. And b1 over b2, what is that equal to? 1 over 2. And c1 over c2, what is that equal to? 5 over 10, which is equal to 1 over 2. Right? Clearly, we see that, what do you see? a1 over a2, 1 over 2, b1 over b2, 1 over 2, c1 over c2, 1 over 2. a1 over a2 is equal to b1 over b2 is equal to c1 over c2. They are all equal. So this would mean the graph as coincident lines, which in turn means the pair of linear equations as infinitely many solutions. You have to state all this. This in turn means the pair of linear equations are dependent and consistent. Dependent and consistent. If they only have consistent and inconsistent, what can we do? We cannot go and explain that there should be another term called dependent and consistent. All we can do is just go and tick the option. So be open. When I say be open, I should use the better word, what is called as be alert. That is what you have to know. And your objective is to score top grades. When I say top grade, it has to be A. Can I say B to be a top grade? Definitely no. Only A is top. Have that in mind. So only the person who completes first, only he is considered as a winner. And it is imperative that you develop that mindset to win. So without further delay, let us move on to the next question. Before we could head on to the next question, if they're asking us to draw the graph and show them that the system is consistent, then we need to draw the graph. So we got the first system, it is x positive y is equal to 5. This is equation 1. We got the next one, it is 2x positive 2y equal to 10. Now always try to represent the graph for y. So when I mean for y, you are writing the entire system with y on the left hand side. So this is going to be y is equal to 5 negative x. And this can also be referred to as f of x. F of x is equal to 5 negative x. So you have a function here. So this is how you need to represent so that you can draw the graph. Now how are you going to draw the graph? First you need to have a table. So you need to draw the table. So you can draw a small table in this fashion. Try to use the ruler so that it can be neat. The more neatness you bring to your work, of course you need to also get the solutions right. That is also important. But neatness with the solution will put you on top. So you have to have a table like this. Make sure you complete the table. I've seen some of them are actually leaving the head and the foot, and simply they keep drawing lines. So also make sure that the line, the division line ends exactly. Don't try to bring it out. And there's a lot of difference between drawing a table like this and drawing a table without the head and the foot. I will explain to you later on when we draw graphs. So now coming up, we have to take x and y. Now you can choose smallest value. If I were to take x to be as 0 and I get y to be as 5, x to be as 1, then y will be 4, x to be as 2, then y will be 3. So this is the graph. Now if you were to draw the graph, let me show to you how the graph looks. Another important tip or side note I wish to give you is when you draw the axis, place 0 and you make sure that you got an arrow on one end, at least in one end. You don't have to put an arrow here and here, but you need to put an arrow for the axis. So this is x-axis, this is y-axis. This is important. Now x is 0, 1, 2, 3, 4. Y is 5, 4. So this is going to be 1, 2, 3, 4, 5, 6, so on and so forth. When x is 0, y is 5. 1, 2, 3, 4, 5. When x is 1, y is 4. 1, 2, 3, 4. So this is the point. When x is 2, y is 3. 1, 2, 3. So this is going to be the point. Since we don't have a graph sheet, we will have to adjust and draw the points. Okay, so if I were to, I want to know where the intersection takes place on the y-axis, on the x-axis. So for that, y is equal to 0 means I need to take y is equal to 0. So this would mean x will be equal to 5. So exactly at 1, probably since I have taken in different scaling, that is the reason the graph is shooting out. So what I will do is I will have to 1, 2, 3 place 5 over here. 1, 2, 3, 4, 5. Graph is not to scale, and I'm trying my best because it's a free flow, right? It's a freestyle. So this would be the intersecting point, and the best thing to do is to name the point. So this is 2, 2, 3, and this is 1, 4, and this is going to be 0, 5, 0. This is the intersecting point. Now we got the another system, right? We got system 2. System 2 is 2x positive 2y is equal to 10. Now what is this? This is nothing but you have to divide by 2. You get x positive y is equal to 5. And what is this? You can rewrite this as y is equal to 5 negative x. You see, y is equal to 5 negative x, y is equal to 5 negative x. You get the same thing. So if they ask you to draw the graph and show that the system is consistent or inconsistent, what I would suggest to you is start with algebraic way and then define it well and then make sure to draw the graph. So in that way you are bringing in multi-dimensional view to a single question, and that is a good point. And of course you might say, oh, we don't have time. Well, learn to do things faster, and that would means you need to have more practice. You need to practice, practice and practice. Practice makes perfect execution. So having given you this, let me move on to the next question. Okay, let's do question number 2. So we're given this x negative y is equal to 8 and 3x negative 3y is equal to 16. So foremost, write down the values of a, b, c. In other words, let us take the values as a1, a2 and b1, b2 and c1, c2. So over here you got a1 is equal to 1, b1 is equal to negative 1 and c1 is equal to 8. you can use this sign. This sign means implies. So this implies A2 is equal to 3, B2 is equal to negative 3, C2 is equal to 16. Now you consider A1 over A2. A1 over A2 is 1 over 3. Consider B1 over B2, it is negative 1 over negative 3. And you consider C1 over C2, which is 8 divided by 16 is 1 over 2. So we observe that. What do we observe? A1 over A2 is equal to B1 over B2. Since this is negative 1 divided by negative 3, it's going to be positive. So you can write that A1 over A2 is equal to B1 over B2. But C1 over C2 is 1 over 2. So this is not equal to C1 over C2. So this means the graph consists of what? Consists of parallel lines. Parallel lines. So this means the system is, what can you say if they are parallel lines? The system is inconsistent. System is inconsistent. That's the important conclusion you need to have. Now you can draw this. I leave it to you. You have to draw the graph in the manner that I've just shown you. So take the points, draw the table and plot the points. So that is your responsibility. If you have any issues, place it in the comment section. I will respond to you. Now question number 3. Let's move on to question number 3. Question number 3 is 2x positive y negative 6 is equal to 0, and you got 4x negative 2y negative 4 is equal to 0. So we will have to check if the system is consistent or inconsistent or dependent and consistent. So from here I can write A1 is equal to 2, B1 is equal to 1, C1, I'm going to take C1 as, you can either take it as negative 6 or if you move it over here it's going to be positive 6. Anyway, it doesn't matter. I'm going to take just like that. C1 is equal to negative 6. So from here A2 is equal to 4, B2 is equal to negative 2 and C2 is equal to negative 4. So this is what we've got. Now consider, what are you going to consider? A1 divided by A2. So what is that? 2 divided by 4. That's equal to 1 over 2. Now you consider B1 over B2. What is that? 1 over negative 2, which is 1 over 2 with a negative sign. And once you have A1 is not equal to, in fact A1 over A2 is not equal to B1 over B2, you can outrightly go on to say clearly, probably that's a better word, clearly A1 over A2 is not equal to B1 over B2. So this means the graph will intersect. The graph will have lines intersecting at a unique point. So this means you can either state it as pair of linear lines or you can simply say the system is consistent. You can use that phrase. And you can draw the lines. So what I wish to do is I would like to take equation 1. Equation 1 is 2x positive y negative 6 is equal to 0. I keep y here, I move everything to the other side. So this is going to be 6 negative 2x. So let's draw the table or the tabular column. This is going to be x, this is going to be y. You can take 0 to be one value, and then I'm taking 2 and 3. When x is 0, y is 6, when x is 2, 4, and that would be 2 here. And when x is 3, 3 2s are 6, 6 negative 6 is 0. So if you were to draw the graph, I can clearly see the positive side alone being predominant. So 0, 1, 2, 3, 4, 5, 6, 0, 1, 2, 3, 4, 5, 6. This is 6. So when x is 0, I would have a point here. When x is 2, I would have a point here, 1 and 2. When x is 3, I have a point here. This is the point I've got. So I can actually connect the points. Let me just finish up with the other one. So from 2, what do you got? 2. 2 is, this is 4x. This is what is given. 4x negative 2y negative 4 is equal to 0. I will move 4 to the other side. So 4 negative 4x. I'll divide by negative 2. So this is going to be negative 2. This is going to be positive 2x. So you have a system of this fashion. So you can in fact write it as 2x negative 2. It's up to you. So having got that, let me draw the table for this. So x and y, when x is 0, when x is 0, y is minus 2. When x is 2, that's going to be 4 minus 2. That's going to be 2. See here, 2 and 2. This is the intersecting point. When x is 3, 3 to the 6. 6 minus 2 is going to be 4. So let's plot the point 0 and minus 2. When it is 0, I have a minus 2. So that means I will have to 1, 2, minus 1, minus 2. So this would be the point 0 and minus 2. So there is a hit there. And 2 and 2. So there is a hit there. 2 and 2. And 3 and 4. 3 and 4. 1, 2, 3, 4. There is a hit here. So if I were to draw the point, let me draw this point, or I would say this set of points. And when x is equal to, we should have actually got for y, when y is equal to 0, that's correct. See, when y is equal to 0, you have 2x minus 2. So 2x is equal to 2. Therefore, x is equal to 1. So this is a point where the graph intersects the y-axis. Now coming to the other end, let's do the other one. Now these are the 3 points which we have already obtained. We'll just go and draw that. So this is a beautiful graph. So you can just place an arrow there. So this is the intersecting point. Intersection is occurring at 2, 2. So this is the only solution for this particular graph. And that's the reason it is consistent. Now you can solve the system and obtain it by means of algebra. What I have done here, I have just approached it from the check for consistency and by graphical method. And having mentioned that, I will wrap up this particular class and we will meet again.